So let's look at checking continuity at a point versus discussing the overall function's continuity between say two intervals. Okay, so what we had done in previous class was something like this. Okay, in our previous class we had done something of this manner. Okay, so let's say we had a function, you had a function like this, say there was a function like this. This is y equal to f of x. And in the previous problem, what you did, you used to pick up a particular point, say x equal to c, and you used to check whether the function is continuous at that point or not. Okay, today what we do is that today we pick up say two intervals. Okay, this is one interval. Okay, and there is another interval out here. There are two intervals, and let's say these intervals are something like, let's say this interval is a x equal to a, and this is say x equal to b, and we are considering the closed interval ab. Now we will be discussing continuity of functions in this interval. Now here you are not given a particular point, so you have to choose your point in such a way that your point is any random point within this interval, and for that random point, if you can prove that it is continuous, then function is continuous. We will take any random point, okay, and for that random point we will try to prove that whether the function is continuous or not. And if the function is continuous in that random point, then we will say that the function is continuous. Let's see some examples of this. Say number one, we have a problem now. Say, though we have done this before, f of x equal to say modulus of x, right? Discuss the continuity of this function. They're not asking us at any particular point. So we first break this function. F of x will be written as what? It will be x if x is greater than or equal to 0, negative x if x is less than 0. Have you understood? All right. So a way of seeing this problem is like this. See, one way of looking at this problem is somewhat like this. Let's say everything is happening around a point which is say 0. This is 0. Okay, 0 included, and if I'm going on one particular side, I have, say, sorry children, 0 included, and if I move on this particular side, there is one sort of a definition, and 0 not included on the other side, there is one sort of a definition. We'll try to solve it in a different manner now. Okay, let's say we now say that let and this function we are checking the continuity on say R, on the real number system. Okay, we say let C belong to R, let C be a point which belongs to R, and we further put a condition, C is less than 0. That means C is any point which is dancing from here till negative infinity. Agreed? Then we say find out what is limit x tends to C f of x. So it will be automatically limit x tends to C. Now which f of x will you pick up if it is less than x minus x? So we say that negative of x, right? And you can straight away put it is negative C, right? F of x, if it is less than 0, we put negative C, right? And we try to find out the value, what is f of C, right? What is f of C? So it will be negative of C. Clear? Now, can you say fx is continuous for all C belonging to R where C is less than 0? Means from here to here the function is continuous. Clear? Okay. Let's check now. This is just another way of doing it. Let C belong to R and C is greater than 0. C is greater than 0, not equal to 0, greater than 0. Okay. Then let's try. limit x tends to c, f of x. We will say it is limit x tends to c. Which function will you pick up? You will pick up x, because this is for anything that is greater or this, right? So what do you get this value as? C, right? And what do you find for f of c? C, right? So function fx is continuous for c. This is maximum descriptive that you can be. C greater than 0, c belonging to R, right? Now check at c. At c, x equal to c, fx is defined. There is no question about it. The function is defined. They have defined the function. And what is the value of f of c? It's c. And if you want to take limit x tends to c, f of x, what is the value you will take? Limit x tends to c, x, which is equal to c. So the function is continuous at c also. Therefore, you say fx is continuous at c equal to 0. That's just a small mistake, huh? This is a small mistake. This is a small mistake from my side. So we are done for 0. Now we say at c equal to 0. At c equal to 0, right? At c equal to 0, limit x tends to 0, f of x. You should take it as limit x tends to 0, x, which is equal to 0. At c equal to 0, limit x tends to c, f of x should be equal to limit x tends to c, x, which is limit x tends to 0, right? And we put here x, which is 0. Now is it fine? You're at c equal to 0. C was a point here, c was a point here, c is a point here now, right? And what is f of c? Is f of 0, which is also equal to 0. Therefore, fx is continuous at c equal to 0. So we write fx is continuous. Fx equal to mod x is continuous. You have checked at all 3 zones. Are you getting the logic now how to check these problems? Whenever you get a problem which will have a piece function for you, your job is to check the piece on whether on the left hand side, whether on the right hand side, and then on the point itself. There will always be a critical point for such functions, and we have to check that critical point, and then we will get that it is right. Let's now see the case of something called rational function. Okay, before rational function, let's pick up one more problem. Let's pick up one more problem. Are we done with this? Okay. Don't get confused. See, it is not about memorizing a technique. It's all about your argument, how you are proving it. So now we will do a problem in which we'll say, discuss the continuity. Discuss the continuity of again a piece function f of x is equal to, right? Let's see the problem. It is a x plus 2 and x minus 2. It says if x is less than equal to 1, if x is greater than 1. Okay. Suppose I'm in the book, there will be graphs drawn from this. Suppose you're not drawing a graph. You very well know that these are what? These are real valued functions. These are polynomial functions, as we call it. Algebraic real valued functions, right? These functions are always plot on the real number axis, and they are always continuous. Any algebraic function or a polynomial function, let's say ax square plus bx plus c, it will be always a continuous function. This piece is also a algebraic function. This piece is also, both are supposed to be continuous. That much sense we have right now. But both have a piece criteria. And there is something happening at 1. There's something happening at 1. That means If I look into I'll not plot this function, though in the book it is plotted. We'll plot, but let's understand. Let's say if I view this function from say minus r to plus r, there is something which is happening at 1. At 1, the definition of the function is changing. Do you agree? So what we will do here, we will check before 1, we will check after 1, and we will check at 1. Right? Common sense says this function has to be continuous in its domain. So you will find here also it will be continuous, here also it will be, but at 1 there will be some garbar which will happen. Because this is an algebraic function, it should be. So let's say, we say our solution would be, let C belong to R. C is any arbitrary point, and we'll first target the top function. And we say C is less than 1. C is less than 1. Right, children? C is less than 1 means I have not touched 1 from this end. Now I'll try to evaluate the limit. Limit x tends to how much? C extends to C, and I write here f of x, limit x tends to C. Children, which function should I pick up now? Because you are going by the criteria less than 1, we'll pick up the top function, x plus 2. You can straight away substitute for C, C plus 2. Right? Let us see what is the value of f of C out here. F of C is C plus 2. Therefore, fx is continuous for C belonging to R and C less than 0. This though we have found out, it is continuous. Oh, less than 1, sorry. Less than 1. Less than 1. कोई problem इसको समझने में? Any issues? No issues. All right. So one part is over. Let's see what is happening beyond 1. So we now write, let C belong to R and C be greater than 1. Limit x tends to C, f of x. Which function will I take this time? I will take x minus 2. So this becomes C minus 2. Agreed? Okay. Limit, sorry, not limit, f of C. F of C, what is the value? C minus 2. Therefore, fx is continuous for C greater than 1, C belonging to R. Now I can write in two different ways. Let C be equal to 1. Let C be equal to 1 now. Right? Here if I write limit x tends to C f of x. See children how I am writing? It can be written as limit x tends to 1. X is C is equal to 1. Na? So I can write x tends to 1 f of x. Which function should I pick? At 1. At 1. So it is x plus 2. Right? Now, what is the value you are getting? The value I am getting here is 1 plus 2, which is equal to 3. Is this correct? Is this correct? We did this, but is this correct? Ask yourself. At 1, what are you finding? Are you finding function value or limit value? Limit value. Limit value is not function value. At 1, there is two definitions for this. One can be approached from left hand side also. One can be approached from, this is a limiting value. You cannot take limit directly. Here you have to approach one from both sides. Right hand side as well as left hand side. Are you understanding now? However, the function value you can approach straight away by this. See, my function value of nose is nose. Limit value of nose can come from left hand side also, can come from right hand side. And when it's typically defined, you don't have that right. So here what we will do, here we are not allowed to go in this manner. we will say, at c equal to 1, we will say limit x tends to 1 minus f of x is equal to, or if you want to increase one more step to show it proper way, then we can write limit x tends to c minus f of x will be equal to limit x tends to 1 minus f of x. Now you tell, 1 minus means from which side function you will take? 1 minus means top function you will take. You're coming from the left side. So you will take limit x tends to 1 minus, what is the value of the function? X plus 2. How much do you get? 1 plus 2. You get a value of 3. Clear? And now we will take limit x tends to c plus f of x is equal to limit x tends to 1 plus f of x, which is equal to limit x tends to 1 plus, what is the f of x greater than 1? X minus 2, which is 1 minus 2 equal to 1. The limit is not defined at 1, though the function is defined. Therefore, we can straight away write function is discontinuous. No further proceeding at x equal to 1. Or we can also write x equal to 1 is a point of discontinuity. Okay? Okay. Since the graphs are given, so children, let us also see whether we can make the graphs. Okay, let's make the graphs. The first equation is y equal to x plus 2. Y equal to x plus 2 will go through the point 2. Do you agree or not? It has to, let's say this is my point 2. It goes through point 2, right? And another point that you want is the slope is 1. The slope is how much? 1. 1 means it will be at 45 degree with the x-axis. So, but mind you, this is up till 1. So your equation of this plot will be only limited till here, because this is defined at 1. This function is defined at 1. This point is 1. It is defined. You have a value here. You do have a value here. You have a value. Right? X equal to minus 2. X equal to minus 2 should be a line which should go through minus 2. Do you agree? Yes. And its slope is also 1. Slopes are same means lines should be parallel. Right? So let's make parallel lines. But it is for all points. It is for all points which are greater than 1. Greater than 1. So my function would be going through, it's supposed to go through minus 2. And it is for all points greater than 1. Tell me how the point will be. All points greater than 1. Minus 2 it will be when x is 0. So you can't touch this y-axis. Ideally, this should touch the y-axis at minus 2, but you cannot take 0. Minus 2 means when x is 0. So your line will be now parallel from here. It will be parallel from here. However, the most striking difference that we will get is here there will be a hole, because you cannot touch 1. So function is continuous, which we proved. Function is continuous, which we proved. But to come from here to here, you have to lift the pen from the paper. So it is discontinuity. Is this clear? We'll do one more problem of this type. We'll do another problem of this type. Was it tattoo or you keep drawing, or mehendi? Oh, mehendi. I thought it was sketch pen you have done. Shall we do one more problem of this type? Interesting. You apply your logic. Similar. There's nothing that you have to copy my language. Okay. Now it says find all points of discontinuity. It is not asking you to discuss discontinuity. It is saying find all points of discontinuity. find all points of discontinuity for a function f, for a function fx, which is defined as, it's again a piece function, and we have x plus 2 for x less than 1, x plus 2 for x less than 1, 0 for x equal to 1, and then it says x minus 2 for x greater than 1. Now you have a greater than, you don't have a, we have three piece function. Some garbar, this itself is a continuous function. Fx equal to 0 is a constant function. Fx equal to 0 means y equal to 0. This is the x-axis, continuous function. This is also continuous. See, now children, you can think from your own side. This is a continuous function, this is a continuous function, this is a continuous function. But is the combination of three a continuous function or not? That is what we have to check. This is continuous, algebraic function. Fx equal to 0 is y x-axis, continuous function. This is also continuous function. This means, acha, can we apply some common sense? Common sense. If we see x plus 2, x minus 2, this should touch 2 and the slope is 145 degree. This should touch minus 2 and the slope is 45 degree. And at 0, x equal to 1 something. So x equal to 1 we have to check. Okay. So our knowledge typically becomes something of this type. Our thought process becomes that this is the real, something at 1 is happening. So let's check this. So let's take our first case. Our first case will be, let C belong to R and C be less than 1. Limit less than 1. Limit x tends to C. X tends to C. And we are checking for what? F of x. So we write limit x tends to C. What is f of x? We will say C is less than 1. We'll take it as x plus 2. So this value becomes equals to C plus 2. What is the value of f of C? We say it is C plus 2. Therefore, fx is continuous for C belonging to R, C less than 1. This zone, it is continuous. So on the first thing, do you have any discontinuity point? No, there is no discontinuity point. Then we go for our next one. We go, what is it happening beyond? Okay. Let C belong to R, C be greater than 1. Limit x tends to C, f of x is equal to limit x tends to C. Which one will I take? X minus 2, C minus 2. F of x, C, C minus 2. Fx is continuous for x for C belonging to R and C is, you can still add one more line. Fx is continuous for x equal to C, where C means C is a point on x. This is understood. Okay, let's see the next one. This is interesting. Okay, now let's say at x equal to C equal to 1, x equal to C and C is equal to 1, right? Now you ask yourself, you want to find the limiting value, and 1 can be approached from both sides. It is defined. Please don't take this for limit. In limit, both will qualify, correct? So we take limit x tends to C minus f of x is equal to limit of x tends to 1 minus f of x is equal to limit x tends to 1 minus. 1 minus means I am coming from this side. So it is x plus 2, which is equal to 1 plus 2, which is equal to 3. Limit x tends to C plus f of x is equal to limit x tends to 1 plus f of x is equal to limit x tends to 1 plus x minus 2, 1 minus 2 minus 1. Therefore, x equal to 1 is a point See how I've changed my language. I did not write the word fx is continuous or discontinuous. I'm right because my hunt is to find points of discontinuity. Fx x equal to 1 is a point of discontinuity. Therefore, fx x equal to 1 is a point of discontinuity. That's it. No more thing required. And if you want to plot your graph, we can plot our graph also. Let's plot our graph. You are able to plot graph because these are easy functions. Okay. So what does this graph say? If your x is less than 1, if your x is less than 1, then it is x plus 2. Children, tell me, x plus 2 is a line which should be touching what point? It should be touching the point 2 on y-axis when x is less than 1. Means now we will touch 2. We will touch 2. So we will touch 2 this. And the interesting part is this point will be included. Did you understand? X plus 2 and x is less than 1. Children, this function is like y equal to x plus 2. If you put the value of x as 0, y is 2. But are you allowed to put x equal to 0? Yes. It helps you. Here it is x minus 2. So graph should touch minus 2. But you don't have that right because it will touch minus 2. Here it will be what? Y equal to x minus 2. Only when you put x equal to 0, but you don't have the right to put x equal to 0. So all x greater than 1, right? So definitely we should mark something called 1 out here. This is my point 1. So for all 1 greater than 1, we will have, and this is for all less than 1. So the first graph is also wrong. The first graph, 1 minute, first graph went wrong. So the first graph will be like this. Don't memorize anything. First graph went wrong because the first graph will be like this. This point is 2. This point is 2. And it should, it will touch this point 0 for all point less than 1. For all point less than 1 means we should have extended it up till. And here we will have a circle, right? And this point will be 2. We'll have a circle out here. And what is this point, children? This point is this point is, this is 1. This is 1. And the next graph should touch minus 2 if x is greater than 1. So it will not touch minus 2 and the graph will dance from here. The graph will dance from, will be parallel to, should be able to come till 1, but we will not be able to bring it because we don't have the authority. It should be always good. This. And at x equal to 1, if the value of 1, then what does the graph say? At 1, the value should be 0. So it is defined here. Now, see, these are the 3 values. Got it? At 1, it is defined. Above than 1, it goes in this manner. So it's discontinuous. Shall Okay, let's take one more. Shall we? Now, you try to do. Discuss the continuity of the function. Now we have a function. Discuss the continuity. It is not asking you to find points of discontinuity. Discuss the continuity of the function x plus 2, x less than 0, x minus 2, x greater than 0. X plus 2, minus x plus 2. So minus x plus 2, x greater than 0, x less than 0. Fine. So everything is happening at and around 0. Do we agree? Everything is happening in and around 0. And there is no definition given what is happening at 0 also. No definition is given. What do you think it should be? this function should be? Use your common sense. This is an algebraic function, continuous. This is algebraic. What does your heart say? You tell me. Should be continuous, but tell me continuous where not. You cannot just say continuous. You have to say continuous means where is it continuous? First, try to identify the point. What is the point where the garbage is expected? 0. So there are 3 zones now. 0, beyond 0, beyond 0. I think there is no issue beyond 0, beyond zeros. But what is happening at 0? What is the value of the function at 0? You tell me, only looking at this. What is the value of the function at 0? Not defined. Not defined. I have not defined. Do you see anything where it says at equal to 0? So 0 is a point of discontinuity straight away. This function defines anything less than 0, anything more than 0. Where is the 0 point definition? Are you understanding? Clear हो रहा है अभी धीरे धीरे. या बिना देखे आप बोल सकते हो this will be discontinuous at 0. 0 का तो definition नहीं है ना हमारे पास. Ananya, did you understand this? It's not defined at 0. So if we even do it like, say, if we do it like, try to do it less than 0, more than 0, and then 0 you try to do. So what we will write here, let C belong to R and C be less than 0, limit x tends to C, f of x will be limit x tends to C. Now you're getting C less than 0, so you will take x plus 2. So this value is C plus 2. F of C is C plus 2. So fx is continuous for x equal to C, for all x equal to C. You should write like this basically, where C belongs to R and C is less than 0. fx is continuous for all x equal to C. This is English. For all x equal to C, all the x's less than C. Okay, so let's take one more example now. This is the proper way of writing actually. So we say the next one, let C be greater than 0 and C belong to R. Limit x tends to C, f of x is limit x tends to C. Now we are greater than 0, so our value will be minus x plus 2, which is 2 minus C is the answer. Agreed? F of C is also equal to 2 minus C. So fx is continuous for all x equal to C, all x equal to C, where C is greater than 0, C belongs to R. Now is the interesting explanation we will write. We'll write f of C where C is equal to 0, that is f of 0 is not defined. We told you now, function should be defined. What is the meaning of function should be defined? Function should have a value. Function does not. Therefore, 0 is a point of discontinuity. Children, something has entered head or not, you tell me, is a point of discontinuity. Clear? One more. Let's see a rational function, okay? Let's see rational function. F of x is equal to 1 upon x. How does this function look like? How does this function look like? How does this function look like? Then you will get the idea of rational functions also. Let's see. Rational function. What does rational function say? You just apply your common sense. If you put 1, you get. If you put x equal to 1, you get 1. If you put x is equal to 2, then you get y is half. Right? So if you take very big figures, then the value of x is, if you take big figures, the value of y reduces. Means if you take big figures, the value of y reduces. If you take small figures, the value of y increases. But at 1, the value is same. So this function will be an asymptote which will bend at 1. This is 1. At 1, both are 1. For large values of x, y values are small. For large values of y, x values are small. As simple as that. So this is an asymptote graph. But my dear children, we only considered positive values. There can be negative values also. So the negative values will be, again a -1 will give -1. So it will be a mirror image like this. Imagine, this is my graph, right? Now, look at this point. X tends to 0. X tends to 0. If x tends to 0, then f of x tends to either positive infinity or f of x will again tend to negative infinity. When x tends to 0, when you're coming to 0, you can come to 0 from both sides, right? If you're coming to 0 from both sides, one side you are giving positive infinity, one side you are getting negative infinity. So is the left hand limit equal to the right hand limit? No. Is the function then does the function have a limiting value at 0? No, the function does not have a limiting value. Are you understanding? I am saying that limit x tends to 0 minus f of x is not equal to limit x tends to 0 plus f of x. Why? Because if you approach 0 from this side, then you get positive infinity. On this side you get. I am approaching 0 from this side, I go to negative infinity. I am approaching 0 from this side, I go to positive infinity. Therefore, the limit does not exist. Hence, this function can never be a continuous function. What is the point of discontinuity? 0 is the point of discontinuity. Is it getting clear? 0 is a point of discontinuity because the function does not have the same limit values at 0. That means the function does not have a limit value at 0. No point in checking anything else. The function is straight away said to be discontinuous. Clear? In similar sense, let's try to do one more problem. What is the problem? Our problem is like this. We have got x and x square. If x is greater than or equal to 0, if x is less than 0. No need to draw graphs. We will go by our choice. So we go by our choice. Let C belong to, this is a parabolic function, real valued function. C belong to R and C is greater than 0. C is greater than 0. Let's take it. Limit x tends to C f of x. Which function will I consider? I will consider this function x. This is equal to C. Perfect, bacha. F of C is equal to C. Therefore, fx is continuous for all x equal to C, C belonging to R, C greater than 0. One thing we have done. Okay, let's find now. Let C belong to R and C be less than 0. Limit x tends to C f of x, limit x tends to C x square C square. F of C is equal to C square. Therefore, fx is continuous for every x belonging to C. C belongs to R, C equal to C, C belongs to R, C less than 0. This is also done. right? Now we are checking at x equal to c equal to 0. X equal to c equal to 0. What is the value of f of 0? What value we will take for f of 0, children? This value, 0. This value. And but the limit you can't take that because there is two definitions for the limit, right? There are two definitions. This is function value, but 0 can be approached from both sides, and there are two different things. So we take the limit. Limit x tends to what? C minus equal to limit c minus f of x is equal to limit x tends to 0 minus f of x, which is equal to limit x tends to 0 minus means this side you will take what? X square, which is equal to 0 square equal to 0. ठीक है बच्चा? Limit x tends to c plus f of x is same as limit x tends to 0 plus f of x is same as limit x tends to 0 plus x. 0 plus means on this side, and this value is also 0. Wow! So we say limit x tends to 0, f of x is equal to f of 0. Therefore, fx is continuous at x equal to 0. Based on the three findings, you can now conclude fx is a continuous function. Function on what? On R. Basically, you checked it on R. You checked it on R because your C was on R. Once 0 case side, once 0 k that side, once on 0. Interesting? Picture is getting clear? Very good. Very intelligent children. Come. Do you know this function called greatest integer function? Okay, let's discuss that. That's the 11th topic. Let's discuss that topic first. Can I go ahead? Okay. We talk about a function called greatest integer function, and we denote it like this, which is like y equal to x, or we write it as f of x equal to x. Don't break your head too much. Simple. Output is always a integer, greatest integer. Input is a real number. Have you understood? Example. This is input, this is output. Fx equal to greatest integer function. Is 0 an integer? Yes. It should vomit how much? Puke? 0. 0.1. 0.1. The greatest integer between 0 and 1 is 0.1. Yeah, 0.1. So what should it put? The greatest integer. Greatest integer. It will puke how much? 0. How close you are? No, greatest integer. No, it's not like that. It's like, yeah, if the input is 1 minute, huh? If the input is 1 0, 1 minute, huh? Even I got confused. He said like this. Yeah, if the input is 0, if there was 0.1, 1 minute, huh? I myself got confused. Just a minute. One minute, huh? Greatest integer less than or equal to x. Yeah. Greatest integer, it is supposed to give you always the greatest integer. We are correct. Less than or equal to x. Less than or equal to x. So come. Don't worry. This is your x and this is your y. You are inputting 0, you get 0. Less than or equal to x. Now you are inputting 0.1. Less than or equal to. So you get a 0. Have you understood? If you put a 1, if you put a 0.9, you still get a 0. If you put a 1, you get a 1. If you put a 1.2, then you get what? 1. Have you understood? So let's just see its plot. Nobody gives you a question, but just let's see the plot. It becomes interesting on the negative side. Less than or equal to. Okay, negative side. If you take this value, negative 0.1, then it should plot -1. Less than the integer. See, this is one integer and this is one integer. Suppose you are greater than 0. Your real number you are inputting, this is your input. Then it should plot, this is say Z1 and this is Z2. Whatever you input, it should take what? Z1. Got it? This is negative Z1, this is negative Z2. And you input this. Then which one it should plot? Negative Z2. Because greatest integer. Alright. So tell me, children, just let us use some common sense. If I input 0, I should get a 0. This is called a step function also. Right? If I input 1, I should get a 1. If I input 2, I should get a 2. No questions? If I input -1, I should get -1. If I input -2, I should get -2. Is this clear? If I input anything from 0 to 1 but not 1, I should get what? 0. So I should get 0. But here I cannot use this value. See, this value is beta 1. I cannot use this value because at 1 it will take 1. Confusing? Should I repeat again, Zoe? Your face was a little bit blank, that's why. Okay, let's see. Is this defined? These are all defined. At integer points, see children, you have no problem at any integer points. At 3, 3. At -3, -3. Is this clear? I input anything between 0 and 1. I input anything between 0 and 1. My plot should come 0. My plot should come 0. So anything, so if I say put 0.1, 0. So I'll be plotting on this axis itself. But when I come and I input 1, I can't touch here. My point goes here. That means at 1, here the function has a break. It's a greatest integer function. 0.9, 0. What is this point, beta? 0.90. Just imagine what is this point. This point is a 0.9 on the x-axis, 0 on the y-axis. Do you agree? Okay. Now after that, so I don't have a plot here. Similarly, when I start plotting from 1, I can go ahead, but when I come to 2, I don't have a plot here. Again from 2, I can go on plotting. Right? So these are all points of discontinuity. Let's look this side. How it will be? Sir, you can keep on plotting any number, you will get a -1 plot, but you cannot take this. You can take any number, but you cannot take this number. It's called a stair function. So these are the points of discontinuity. So the greatest integer function is a discontinuous function. Okay? And you cannot define it. If you want to define it, let's say you take this region. Let's say you take this region, okay? Let's say we take a number C out here, right? This number beta C is between which two integers, you tell me? This is between 1 and 2, right? 1 and 2. You want to find the limit here. See, Zoe, apply this. You want to find the limit at C. You can approach C from this side, you can approach C from this side. If you approach limit x tends to C minus, means you are approaching C from this side, then what is the value you get? You will get 1. This one. And if you approach from this side, means you are approaching from 2. Here you will get 2. Discontinuous. Clear? Then we have something called algebra. We'll spend one more class also, don't worry. Algebra of continuity. But don't go by those composite. Composite functions, this NCERT doesn't know how to print the syllabus. Composite function is not there. So because they can't omit it, they don't want to print new pages. You will have something called GOF and all written out here, but that does not apply because you have not studied this part, composite function. This cannot come because your composite is not there in your syllabus itself. So let's see algebra of continuous functions. What is the algebra? If fx is a continuous function and gx, both are continuous, both are individually continuous, then number one, their sum will also give a continuous function. Is sin x a continuous function? Yes, it's a wave. Is cos x a continuous function? Yes, sin x plus cos x is a continuous function. Similarly, a continuous minus a continuous is also a continuous function. Similarly, a continuous into a continuous is a continuous. So somebody tells you sin x cos x, sin x cos x, is it a continuous function? Yes. 4. Here we have a lafra. This is continuous except when gx becomes equals to 0. Because if gx becomes 0, this function is not defined. It cannot be continuous. A very nice example is the function tan x, fx equal to tan x, right? Fx equal to tan x can be written as what, beta? Sin x by cos x. Now, sin x is continuous, cos x is continuous. However, cos x is equal to 0 when x is equal to 2n plus 1 into pi by 2. Means 2n plus 1, n can be equal to 0, 1, 2, 3, right? At all 90s, at all odd multiples, cos becomes 0. Therefore, we say fx equal to tan x is continuous on x equal to r except for points x equal to 2n plus 1 pi by 2. Sir, we don't believe you. Please don't believe. So we have to give you some extra proof. Let's see some extra proof. Let's go to the chapter of inverse trigonometric identities. All right. Huh? Zero, pi by 2, pi, then 3 pi by 2, 2 pi, minus pi by 2, minus pi, minus 3 pi by 2, and 2 pi. Tan 0, 0. Tan is defined for 0. But sir, there is a issue. What is the issue? The tan graph will always come like this and go like this. Sir, how about tan pi? Tan pi is 0. How about tan 2 pi? Sir, at tan 2 pi, it will give me a 0. How about tan pi? Sir, at tan pi we will get a 0. How about tan 2 pi? Sir, at tan 2 pi we will get a 0. Look at your function. Your function is discontinuous. At these values, the function does not touch the y-axis. Clear? So when such composite functions are given, apply these rules. Okay, somebody tells you, on your common sense, will not solve. Check the continuity of the function fx equal to 2x plus 3 into sine x. Tell me, is it continuous or not? Sine x is a continuous function. This is a continuous function. It's a continuous function. That's not life is becoming easy, right? So that's it. We don't have anything more. Now we have to, this Goff and Fogg, you leave it. Goff and Fogg is not in your syllabus. So now we go to exercise 5.1. There are many piece functions out here. Pick up your piece functions. Let's see one function. Let's see one particular function before you go back home. Let's say we have a function. You tell me, okay? F of x. Now you'll develop the intellect to solve it. Sin x upon x and x plus 1, x less than 0, x greater than 0. Okay? Don't worry. I'm not deliberately not putting the question number. Okay? X less than 0, x greater than or equal to 0. Now see, children, 0 is the Garbari point. Right? There is a definition for less than 0, 0 as well as greater than 0. But one thing we are finding a problem is that this is an algebraic function. No question about it. This is always a continuous function. Right? If you look here, it's a trigonometric over algebraic. Is a trigonometric sin x continuous function? Yes. Is an algebraic continuous function? Yes. But it can throw a value 0 also. But the question says, you're gonna take this only when it is less than 0. So this can never be undefined. One thing is for sure, this is not undefined. Right? And this one is also defined. So let's do some quick checks. Quick. Limit. X tends to 0 means 0 minus. Now we are leaving CV all. 0 minus. Now you can say, sir, again you change away from 0 plus and C and all, you are coming to 0 minus. Array, what stops me? Can we not do that? Aajao, bacha. X tends to 0 minus. Which function will you take? Quick. Sin x by x. Acha, this is an identity. Limit x tends to 0, sin x by x is equal to 1. This value is equal to 1. Now 0 minus I am saying, but 0 minus itself is the limit on this side. Okay. The limit is defined. Now what do you do? So this is defined. Right? So we have a limit value on this side. Acha. If you want to take the value of f of 0, what is the value of f of 0? 0 plus 1, 1. So the function is defined for all 0 minus. I said, don't confuse. You will say, sir, he did not take right hand limit, but he is only doing array. I have taken right. This left hand limit itself is one limit now on this range. Or if you want to do it by C, you can do by C. I'm just trying to do it fast. Limit x tends to 0 plus f of x. Which function will you take? 0 plus this function. You will take it as limit x tends to 0 plus x plus 1. The value is 1. Then again, f of 0 is how much? 1. Right? And if you want to check limit x tends to 0, then which function you will take? Still you will take x plus 1. This is also 1 and f of 0 is equal to 1. This whole function is continuous. But you can do it by taking CC way. Okay? I took it this way, but you preferably do it by C. C matlab samajh gaya na? First you will say let C belong to R and C be less than 0. Then how will you write this function? You will write limit x tends to C, right? And f of x is equal to, now you will write it as what? Limit x tends to C, and this becomes sine c by c, which is 1. This is a limit function. Okay, limit. This is a defined limit. Try करेंगे अभी. If I think that you are good enough and you don't come with queries, we can start, and I'll start with basic of differentiation. How you got that formula? Because this year we will not use that formula, we'll go by normal differentiation. Now tell. Okay, let's